In this video, we'll be graphing logarithmic functions. We'll graph each logarithmic function, possibly involving transformations. We'll state the domain and range in interval notation and identify any asymptotes. So let's graph f of x equals log base 1/2 of x. Please note that most calculators cannot evaluate logs other than our common log or our natural log. Those are the buttons that most of us see on our calculators. In the case where we want to obtain points to the graph of a logarithmic function that's not one of these, log base 10 or log base e, we're going to use the exponential inverse function to help us get the points. So here are steps for graphing a log function using an exponential function for help. We'll start by identifying the exponential inverse function. We'll convert from logarithmic form to exponential form. But basically, it's just the base number raised to the x power. Then we'll obtain 4 points for the exponential function, just as we've done before. Lastly, we'll interchange the x and the y coordinates, since they are inverse functions, to obtain the points to the logarithmic function that we're actually trying to graph. Okay, so to graph log base 1/2 of x, I'm going to start with the exponential inverse. And I'm going to clearly denote that it's the inverse so I don't accidentally think this is the graph I'm supposed to be graphing. So f inverse of x is going to be equal to, now the bases are the same, so 1/2, and it'll be raised to the x power. We'll make an XY chart to get our 4 points for this inverse function. We'll choose the same x values as we always have for exponential functions, -1, 0, 1, and 2. Plugging into our exponential function, 1/2 raised to the -1 power is 2. 1/2 to the 0 is 1. 1/2 to the first is 1/2. And 1/2 to the second, 1/4. Now, those are not the points that we want to graph. Those are the points for the inverse function. To get the points for log base 1/2 of x, we're now going to interchange the x and the y coordinates. The points that we want to graph for f of x equals log base 1/2 of x are going to be 2, -1, 1, 0, 1/2, 1, and 1/4, 2. Interchange the x and the y values. Now we plot these. Two, -1, 1, 0, 1/2, 1, and 1/4, 2. Recall that our logarithmic functions have a vertical asymptote on the y-axis. These 4 points need to connect, and one end of our graph has to tend towards the vertical asymptote. It's definitely going to be the end that's already close to it. And there's the graph of f of x equals log base 1/2 of x. We also want to state the domain, the range, and the equation of the vertical asymptote. Our domain is 0 not included to positive infinity, while our range, since we have an arrow pointing up and an arrow pointing down, negative infinity to positive infinity. Our vertical asymptote is on the y-axis, and the equation of that line x equals 0. Let's look at one that includes some transformations. We want to graph g of x equals log base 4 of x minus 2. I know that this is going to involve transformations because I have a number inside of the argument. Our basic log functions just have log base of a number and then just x inside the parentheses. So I see that I have a single transformation there. Like any graph by transformation, I want to write out my plan. We'll start with our parent function. That'll be g of x equals log base 4 of x. Our parent function is a logarithmic function, so we do not need to have the word log, the base number, and x in the argument. And then a single transformation, minus 2 on the inside, tells us that we're going to move to the right 2 units. Now we need to graph. Well, my parent function is g of x equals log base 4 of x. Well, that's not one that my calculator can do. So I'm going to need to use the exponential inverse to help me get points and then interchange the x and y. So g inverse is going to be equal to 4 raised to the x. We'll make an xy chart. Using x values of -1, 0, 1, and 2. 4 to the negative first is 1/4. 4 to the 0 is 1. 4 to the first is 4. And 4 to the second, 16. Now these aren't the points we want to graph. To get our logarithmic function, we're going to need to interchange the x and the y coordinates. So the points for our parent function will be 1/4, -1, 1, 0, 4, 1, and 16, 2. 1/4, -1, 1, 0, 4, 1, and 16, 2. All of our parent logarithmic functions have a vertical asymptote on the y-axis. One of our ends has to tend towards that asymptote, and it'll definitely be the left side. We draw in our graph. Unlike exponential functions that grew really fast, logarithmic functions grow really slow. And the larger the base is, the slower they grow. All right, that was our parent function. We do have one transformation. To graph our final answer, g of x equals log base 4 of x minus 2, we need to shift to the right 2 units. This will affect the x coordinates. We'll need to add 2 to all the x coordinates. So we'll have 2 1/4, -1, 3, 0, 6, 1, and 18, 2. Before we plot those 4 points, I'd like to talk about the vertical asymptote. Is that vertical asymptote going to be affected if we shift the graph to the right 2 units. Yes, it is. It will also have to shift to the right 2 units. And now we'll draw in our points. 2 1/4, -1, 3 0, 6 1, and 18 2. And there's our final answer in red. Now we want to state the domain, the range, and the equation of our vertical asymptote. Our domain, we turn our attention to that vertical asymptote. Our domain will be not including 2 to positive infinity. Our range, -infinity to positive infinity. I know it looks kind of like our graph levels off as if there's a horizontal asymptote there, but it's not. It's growing just very slowly. It will slowly get to positive infinity. And lastly, we have a vertical asymptote at x = 2.